Hello guys, so today I've got myself a new webcam and I just want to make this short video to test that it's working correctly and just to see how good it is. So what I'm going to be talking about today is anti-pattern. So anti-pattern is basically something that you should not be doing, but it's not something simple, just like don't drop the user's table every day or don't commit silly cat photos to your repository. What makes an anti-pattern is that it's widely used. So that must be something that people are doing every day, and that something is bad for your everyday programming life. So, um, why do you need to know them? Well, basically that's because of our human nature is that we usually learn by don't but what we shouldn't be doing instead of what we should be doing. That comes from our childhood when parents tell us, you shouldn't be putting your fingers in the socket or you shouldn't be playing with fire and stuff like that. And then as we grow up, we find things that we should be doing and that we like. So I think that applies to programming as well. So first you have to learn the bad approaches so that you can choose from the good ones. And especially that if you're working at an environment where these are prevalent and there's a lot of those, it's nice if you can identify them, because identifying a problem usually is halfway of solving it. So that's even in psychiatry, when people, when the doctor tells you to remember events from your childhood, that's usually because remembering what was the trauma that caused you to behave in a certain way usually makes you less inclined to do so. So that's one way of approaching this. Um, so I'm going to start with things that everybody is at least a bit familiar of. So let's talk about hard code. So hard coding is basically putting into the code assumptions about the environment. So when you put a path to a particular file or a particular folder, or specify the username and the password for the database user, or put some domain that you're using an API from, you're basically hard coding some environment details into the logic itself, and that's something you should not be doing. But there is the opposite side of this, and it's called soft coding. Soft coding is when a lot of your business logic is defined by configuration instead of the actual code. So this a good example of this is validation. In Symfony, when you define your business model, domain model, you can define validators for it in UML, basically by saying that this is going to be a number, this is going to be a string of set length, and this has to be filled and this can be empty. This is in Symfony, that's rather well implemented, because these you are very much limited to what you can do. But even this gets tedious when you have to when you have to remember all of those properties, like and have the list of the available options at hand. Now there are systems that rely on configuration a lot more. So you can where you can specify that there is this kind of interaction between these objects and this kind of interaction between those, and when there is too much of that going on, when your application is so much controlled by the configuration that extending it requires adding a new kind of configuration module sort of thing, you're moving from something that you're comfortable with, which is a programming language, to basically a domain-specific language that is encoded in the configuration file itself, and that should be something you shouldn't strive to do, at least. So these anti-patterns are split into subcategories, but I won't be accessing them in any particular order. I just have them listed for me, so I'm in the order that they came to my mind. and that's the order that I'll be using. So the next one it would be cargo cult programming, which is, I think it right now this is coming a lot to every language, and that's something that's always been there. So that's using patterns and like whatever is fresh and whatever is popular, without actually knowing its strengths and weaknesses, and where it actually has to be applied. So I would say that I think that implementation, using overusing NoSQL, where SQL would be great. That's the idea of this cargo cult programming approach, where something is cool because something is used because it's popular instead of because it fits. Let's see what next. Oh, I like this one. This is something that everyone has seen. This is the not invented here principle, where people are going around reinventing the wheel instead of adopting, an existing adequate solution, just because they weren't the one to develop it. There might be legitimate reasons for doing so. For example, the license may not match your expectations, especially if the license requires you that you can develop only open source software using this library. Then obviously you'd have to rewrite the library. So, but if you're doing rewriting just something because it's because it's not yours, that's the not invented here syndrome. It's kind of prevalent in frameworks and CMSs, where every CMS and framework has to have its own database access service. It has to have its own templating. So we have kind of been moving from this as a community, because there are a lot of packages that are being shared across projects, especially with Composer over here. But there is this other side that's not much better, and it's also an anti-pattern, is the invented here. Now this is a tendency towards dismissing any innovation or less than trivial solutions because you're not confident in your staff or in yourself. So basically, I think this especially this comes to when overusing libraries, the shotgun approach, sort of. This is when you need a small function that would download stuff from a remote HTTP server, and basically, if you wrote 20 lines in CURL, this would fit you ideally. But now you just don't want to. You're not doing this because you want to download a tested solution. So you download the library and use 3% of it, and just because you didn't want to write 20 lines yourself. And some may say this is a good idea because at least that this library is tested and that sort of thing. But on the other hand, when your project as a whole depends on too many small things, then changes to any of those would result in change of your project, and managing too many dependencies is another kind of anti-pattern by itself. So another one that's now I'm gonna go more into actual writing code. So this is the test-driven development. This is named as a pun on TDD, but the idea is that instead of having doing stuff using a specification first, you just do a haphazard, whatever floats your boat right now, a solution, and then fix the bugs as they come reported by the QA team. So this especially a lot of these anti-patterns actually hurt enterprise companies more, because they seem to have a lot of more time to spend on those, and developers generally get more lazy in those. So yeah, but if the developer doesn't know what he's developing but all he does is fixing bugs, this is this anti-pattern. Now this might be there's not a variation but a sister anti-pattern to this, which is development by designed by by committee. So that's like when your client is represented by like let's say five people that are responsible for the project that you're doing for them. A lot of times it happens that on one day client A comes on and says, you know, I want this and this, I want this kind of menu and this kind of pop-up, and it has to be here and it has to have this and this and this. And you say, okay, so you're developing this for 2 days, and then, you know, another person comes in and says, all right, so I don't know what that guy was smoking, but you definitely need to move this to a separate page and do this and this and this. So you were doing this until the third guy comes in, and then you do it again, and then the first guy comes in and he's angry that you didn't do it. So it doesn't really help when those guys talk among themselves on what they want to accomplish, because that results in the analysis paralysis sort of thing. When the same committee that was causing the design by committee problem is now trying to overanalyze the solution instead of, you know, seeing how it works. It can actually and that happens to developers even without the committee, because a single developer can overanalyze the approach to the point when he is thinking on a week on how to optimize something that shouldn't be optimized in the first place, and that's, you know, premature optimization is its own thing. Actually, let's talk about optimization a bit. So there's usually readability and optimization stand on like the opposite sides of programming. So usually if you go for let's say you're trying to do some sort of a search algorithm, graph storage search algorithm, and now if you go with the simple, like you just want to do it fast, you can do it in a simple function, have everything stored in like arrays with specified keys, have a while true loop that would do like a breadth first search, something like that, and just go in loops while it searches for stuff. You could do that. On the other hand, you could define classes for like for like different kinds of nodes, and you know. So like you while optimizing, usually you reduce the readability of the code to gain some performance gain. So premature optimization usually leads to unreadable code, because if you found a great solution online that requires you to traverse a tree in a very specific way, in a year you won't remember that solution, but you know, doing modification to this algorithm would be pretty hard for you. Let's then remember more. This if the next few are actually hurting more the .NET side, because a lot of .NET web stuff has been designed for people who were developing for desktops first. So there's been this movement where they've been I think those were the web forms API. They were trying to design a web forms API similar to how the desktop API works, so that would abstract the idea that there is a browser is separate from your backend server. And how they achieved that was when you defined a form, inside that form you would also define what would happen on like submit, and and to any button in your HTML you could add like an XML tag and say like run this backend function when this you know executes, and change attributes of these elements. So the like div elements and forms that were displayed on the page were actually presented as instances of specific classes on the backend, and you had no idea how that worked, because the data was sent like encoded and encrypted back and forth between the sender and the server and the client. So this is more of like this is called the magic push button. That's basically where there's you don't know how the interaction is done, but you're coding the implementation logic directly into the interface code. I think that's the exact definition actually. The exact definition of a magic push button is coding implementation logic directly within interface code without using abstraction. So you're not abstracting the interaction between the interface and the backend implementation. There is this also yeah, that reminded me of a project I was working on. So there's this other thing that's called a stovepipe system, because that was like one of the large enterprise projects I've been doing. So what a stovepipe system is basically when you have a business that's providing several different services which are similar, but they are designed in such a way that they don't share any data. So even though like that usually your users register in all of your services, you don't have like sort of centralized login, so that there is no data sharing among those at all, and that's why a lot of the logic has to be re-implemented or just plain copy pasted between them. And this is called a stovepipe system because on factories there are stovepipes that don't interact with each other, and even though they belong to the same factory, they are just there apart. Let's talk about this is going to be a bit more complex thing. That's called a database as IPC. It's basically using a database as a message queue, or not even message queue. Yeah, there's basically as a communication mechanism. Yeah, basic message queue between sub processes. And I've been seeing the most weirdest implementations of this. For example, there's like a table cell that's being written 1 when some subtask begins executing, and then gets written 0 when it ends. So when you start the same subtask, in a different thread, it checks that there is already one in the database, so that I want to execute, I'm just gonna schedule myself for later execution. So this could be done with plain simple message queue. But there is a worse thing that you can do with a database, that's basically using database as a platform, basically a software as a platform pattern, where you are, instead of making an app, you start by making a platform. For example, let's take Drupal and its CCK fields component, which is great sort of thing, but it's really extendable. It's still an anti-pattern, so if you're using that, you can add a new content type and add whatever fields you like to it. So the fields can be of any type. For example, I can take the generic post and make an image post content type that has like 2 images that can be attached to it. So usually it's going to have like this meta table additional, like call it fields, and for each item it's going to store a field name and the field value and like the field type. But then when it tries to construct the object back from this, it has to select it from the table, reparse it. It would work much better if each content type got its own table. And I've even seen Vecchio solutions where an SQL database consisted of a single table that was a key value thing that was used, as a key value database store, but made all on an SQL store. So this is some wacky stuff going on. Let's talk more a bit about anti-patterns that are specific to OOP. So we have the anemic business model. So the anemic business model is basically the fat controller thing model, a thing that's been all around the web. So if your models don't hold any domain logic, for example, they cannot validate themselves, they can't provide any useful information. For example, let's imagine that we have a user model. If all our user model does is store properties into the database and get them, it does, and user registration and validation is done by one controller, like user relationships are done by another controller, and logic is stored in those controllers rather than the model. This domain model is useless by itself, so it could just have been an std object going on there. And since it doesn't model anything then I might as well have like two controllers that do two different kinds of validation but store to the same model. So model that was valid in one controller is not valid in the other. This way you don't have any standardized logic sort of thing. There is the object orgy. This is when this kind of arises from the dynamic business model, but that when scaled to the size of your application sort of thing is when everything is public and everything is accessed by everything, especially when you have a lot of static calls and static properties. So this way you are never sure about which state the object is in, and because everything can change all properties of the object, then it's possible for something to bring your objects to an invalid state, and it's usually hard to find those places if it's designed like this. There's also a GAN object and a pattern where there is just one single object that's basically adds like not a huge facade but like a huge nexus of your app that has access to everything, can do everything, and it's practically impossible to test since it relies on everything. So it can't have an interface because it does everything. It breaks everything. It breaks separation of concerns principle. It breaks the interface segregation principle. There's the base bin anti-pattern. That's basically when you have a base class that has all kinds of utility methods that all other classes inherit from, just so they can use those utility methods. So I don't need my database connection class to know how to uppercase strings. There are people doing this like that, and obviously this is much better done with delegation and injection. What else? Kind of late, so nothing comes to mind. I can talk about premature optimization already. There is I like this name, reinventing the square wheel. This is like the not invented here anti-pattern, but just with this additional constraint that the solution you come up with while reinventing stuff is worse than the one that you could have downloaded from the very beginning. There is programming by permutation, but this usually comes when doing stuff like code challenges, so when there is a lot of logic and going back and forth involved. So programming by permutation is when you have when you start making not random but more or less intuitive guesses on what should be changed in the program so that it would work. So even after by accident you make it work, you don't really know how it works. We can go into well, action. I would say action at the distance, but action at the distance is similar to object origin. It's just that it's different in that the parts of the systems are even more far apart from each other. So if you're familiar with like spaghetti code, which is overusing structures, like not even GoTo, you can overuse whiles and for each in the very same fashion. Especially it's nice when there is like a switch in the while and it just loops and just does stuff depending on the switch current state. Kinda lost what I wanted to develop. But in OP world we have like the yo-yo anti-pattern when the inheritance tree of an object is that big and methods are called from like different levels of inheritance. So the developer trying to understand what actually is going on has to jump between 20 classes all the time. There's also an even more advanced idea. Anti-pattern is the lasagna code. That's when your application is built using this basically a service or layered architecture, but the services are so dynamic, and there's such a huge lot of them that tracing how the request goes, jumps between them is hard and unproductive. Um, all right, I think those are pretty all that come to my mind at the point. Oh, there was also the magic hammer and the silver bullet. Basically, two names of the same thing. That's um, when you have a favorite solution and apply it to everything. I think this comes, especially this goes for event-based systems. When you have an event-based architecture and you try to apply it to everything, even to stuff that doesn't need to be event-based. What else? Oh, there's vendor lock-in. That's more of a organizational sort of anti-pattern. That's when you rely too much on a third-party component that is becoming like a central part of your app, and when if it changes or dies or becomes twice as expensive, you basically just have to you're dead, sort of thing. Um, One thing I still remember is probably gonna be the last one, is the called the Peter principle. That's when you take a developer that, let's say he's like an intermediate developer, and you promote him to a senior developer. So now he was pretty good at being intermediate. Now that he's senior, he's kind of struggling, but he manages it. He does a pretty good job, and but you, from the outside, you just see that he manages. So in like a year, you promote him, you just give him a team, and he becomes like a project lead sort of thing. And so you kind of wanted to be a good guy, so you gave him the promotion, but you basically promoted him to the level where he's not competent anymore. So you could argue this. Oh, and just remembered my favorite anti-pattern. That's BDD, buzzword-driven development. That's basically I'm gonna read the definition for you because I was just looking at the list on the wiki and just found it. Adapting new technologies or business methods that are poorly fitting to add new value, often unknowingly, simply because they are the latest crazes in the industry. So this is sort of like the cult cargo development, but the buzzword-driven development usually comes from the desire to be hip, while the cult cargo development comes from the desire to do stuff properly. So they kind of achieve the same result, but in a different way. Yeah, so I think I've talked about all of the ones that I thought were kind of most used. No, but there are definitely a lot more of those, and I would recommend reading the book on them because usually they are pretty funny to read, especially from some good authors that give nice examples. So if you like this video, I'm just gonna upload, just tell me, I'm gonna tell you about more anti-patterns instead of, yeah, thanks for watching this. Bye bye.